Okay, now we have for f of t, we have is equal to the square root of t plus 3 times t. And if we look for the Laplace transform of this function, okay, so we have f of s, the Laplace transform of f of t, and if we itemize, okay, so we can say first of all, okay, we have the Laplace transform of the square root of t, and I can separate this from 3t. So the square root of t we can express as t raised to the 1/2, and with 3 is a multiple, I can say I have 3 times the Laplace transform of t. Okay, so we have with t, okay, the transform is going to be 1 over s squared. Now, in the case of the square root of t, now we have our function at t to the a, and the transform is going to be the gamma function of a plus 1 all over s to the a plus 1. So, like in the case of t to the 1/2, the Laplace transform, we're looking at the gamma of 1/2 plus 1, which will be gamma of 3/2, and we have all over s to the 3/2. And looking at what we have in the listing of what we have for the gamma values. So we have of 1/2, we have the square root of pi, and we have gamma of 3/2, and that is going to be the square root of pi over 2. Okay, so we have in the follow through, so we have the Laplace transform of t to the 1/2. Okay, so we're going to have, again, the square root of pi all over 2 times s to the 3/2. And we have 3 times the Laplace transform of t, again, which is going to be, in this case, you have multiplying 3 by 1 over s. And if we leave the terms separate, okay, we're going to have the square root of pi all over 2 times s to the 3/2. And we have plus 3 over s. And if we look at consolidating as a single term, okay, now the least common denominator is going to be 2s to the 3/2. And if I write as a single term, so I can say that I have the square root of pi and multiplying 3 by 2s to the 1/2, and say I have the square root of pi plus 6 times s to the 1/2, and this is going to be all over 2 times s to the 3/2. Okay, for the next function, okay, we have f of t is equal to t to the 3/2 plus e to the negative 10t. And if I take the Laplace transform of this function, so separating the terms, so we have the Laplace of t to the 3/2, and we have plus the Laplace of e to the negative 10t. And for what we're going to have, at least for the Laplace of t to the 3/2, remember, we got your gamma expression. We're going to have, in this case, you have gamma of what's going to be 3/2 plus 1, which will be 5/2. And this is going to be all over s to the 3/2 plus 1, so we have s raised to the 5/2. And for e to the negative 10t, so we have referencing what we have here for e to the at. Well, guess what we have for e to the negative 10t? Your transform, we're going to have 1 over s minus negative 10. And this is going to be 1 over s plus 10. And again, for the gamma of 5/2, that would be 3 times the square root of pi all over 4. And so for the Laplace transform of what we have in this problem, okay, so you're going to have, again, so you have 3 times the square root of pi by then we can say that we have all over 4 times s to the 5 halves, and we can say that we have plus 1 all over s plus 10. Okay, and if I were to consolidate, okay, so I would have in this case 3 times the square root of pi times the quantity of s plus 10. And we have plus 4 times s to the 5 halves. And this will be all over 4 times s to the 5 halves times the quantity of s plus 10. Okay, so we have with the next function, we have the square root of the cosine of 2t, and if we find the Laplace transform of this, okay, and to make this table friendly, okay, we will write the double angle equivalent of the square of the cosine of 2t. Okay, so we're going to have 1/2 plus 1/2 of the cosine of 4t. And for the Laplace transform, okay, so we have 1/2, and the Laplace transform of 1/2, we can just factor out the 1/2, saying we have 1/2 of the Laplace transform of 1 itself. And we can say we have plus 1/2 of the Laplace transform of the cosine of 4t. And again, just for the number 1, okay, the Laplace transform of 1, okay, that is going to be 1 over s. Now for what we are going to have in the case of the cosine of 4t, so if we look at referencing what we have for the cosine of 4t, so you have your function cosine of kt, where k is going to be at 4, and so for the cosine of 4t, that's going to be s over s squared plus 4 squared, so we're going to have s over s squared plus 16. And if we look at what we have here as separate terms, so we have 1 over 2s, and we have plus s all over 2 times the quantity of s squared plus 16. And if I were to consolidate as a single ratio, okay, well, what is going to happen here is that for 1, I'm going to have s squared plus 16, and then we're going to have s to be multiplied by s. Okay, so we're going to have s squared plus 16 plus s squared. Okay, so initially, once we consolidate, we're going to have 2s squared plus 16 all over 2s times the quantity of s squared plus 16. And if you notice, we have even leading coefficients throughout. And if I consolidate in simplified terms, okay, so taking 1/2 of the numerator and denominator, so this will come out to s squared plus 8 all over s times the quantity of s squared plus 16. Okay, so we have as possible answers. Okay, so without the consolidating, this is what we have as separate terms. And you could distribute and say we have s over 2s squared plus 32. And again, the other version in the simplified consolidated form, we have s squared plus 8 all over s times the quantity of s squared plus 16. Okay, for the next function, okay, we have expressed as the product of the sine of 3t and the cosine of 3t. And let's say that if I consolidate as a single term. And going back to a special double angle formula, where we have like the sine of the double angle, like we have sine of 2t is equal to 2 times the sine of t times the cosine of t. But if I look at working with sine of 3t and the cosine of 3t, say if I have say if I have 2 times the sine of 3t times the cosine of 3t, well, that is going to be the sine of 6t. But to get this in terms of just sine of 3t times the cosine of 3t, I'm just going to take half. So we have 1/2 of the sine of 6t is equal to the sine of 3t times the cosine of 3t. Okay, and so in the rewrite, okay, so as a single term, we have 1/2 of the sine of 6t. So we have in the Laplace transform, so we're looking at 1/2 of the Laplace transform of the sine of 6t. And for what we have, once again, referencing the tables. So for the sine of 6t, where we have k is going to be at 6, with the Laplace transform, we're going to have what's going to be 6 over s squared plus 6 squared. So that's going to be 6 over s squared plus 36. And for what we have in the follow through, so you have half of 6 is going to be 3. And so we have with the outcome, we're going to end up at 3 all over s squared plus 36.